So what you should have picked up from the last video is that although the pattern and the numbers stay the same in binary, we give them a different representation in denary. So this pattern here is just the same that we use in binary. We've just changed the last 8 items here for a different representation for negative numbers. So what we really want to do is do some subtraction. And actually, in computing, or on a computer, subtraction is done just by adding. There is no such thing as subtracting 2 numbers. They add them together. But it's a little bit complicated, and we have to play around with the digits or the understanding of what we've got before we can be confident with what's happening. So let's have a look. If I want to do this sum, let's do 2 take away 1. And I'm going to write that out in binary. And we know what the answer is. 2 take away 1 is 1. Anybody who disagrees with me now, I think you need to switch the video off and go back to maths. So let's take a look at the binary patterns. Here's the binary pattern for positive 2. It's 0, 1, 0. Now this is negative 1. When we say take away something, we're really saying negative 1. So I'm looking for the binary pattern for negative 1, which is 1, 1, 1. And I put those down. And if I add these two together, 0 and 1 is 1. 1 and 1 is 2. So let's put a 0 down, carry the 1. And 0, 1 and 1 is 2. So put the 0 down, carry the 1. Now, I'm in a 3-bit computer and I've got 4 bits in my answer. If I was doing, as per the last set of videos, binary addition, where we weren't looking at negative numbers, this would give me an overflow error. Actually, what happens when we overflow is that there's something called a flag gets set to tell me that there's an overflow, and the computer decides whether it's an error depending on what we're doing or not. This overflow is just ignored, so we always end up with just 3 bits. So I've grayed out the very first bit here, so I've just got 3 bits. Now let's take a look at the pattern of bits. I've got 0, 0, 1, and if I look in my table for 0, 0, 1, I find it here, and that is the value 1. So 2 take away 1 is 1. And the only problem I had was this silly number here, that the 3 1s representing the -1. It's only in the computer. This actually makes no sense to us at the moment. We will see how to make sense of it later. But that is the computer representation of -1. It's not like we could just put a 1 in front of here to make that one -1. So we have to be a little bit careful how we play. So let's do another one. Let's do 1 take away 3. Now the difference here is that I'm going to end up with a negative answer. So 1 take away 3 is going to give me -2. So let's write this out again as our binary addition. I wanted my 1, so I look down my column for 1. That's 0, 0, 1. Place it in my sum. Then I look down my column for -3, which is here, 1, 0, 1, and I write that beneath, and then I add the 2 together. So 1 and 1 is 2. Put down the 0, carry the 1. 0, 0 and 1 is 1. 0 and 1 is 1. My answer is 1, 1, 0. So I go back to my table and I look. Because I've only got 3 bits, that's the correct pattern, there was no overflow this time. I look for this pattern 1, 1, 0 in my table. And 1, 1, 0 is the bit pattern for -2. So 1 take away 3 is -2. Hopefully you're getting a feel for that now, how we're using this table as a kind of lookup for the value we want. Later on we're going to change how we do things, but having an understanding of this table will really, really help you. Let's move this on to 4 bits, and I'm going to do the same sums. I'm going to do 2 take away 1, and the answer is 1. So I'm going to write it out, but the only difference really is the fact that I'm going to have 4 bits in my question. So 2 is 0, 0, 1, 0, and for 3 bits it was just 0, 1, 0. And minus 1 is the very last one again. Remember, we start at minus 1 at the bottom and count up. So minus 1, I seem to have got a problem there. Minus 1 is 4 ones, so I put them there and I add them together. So 0 plus 1 is 1. 1 and 1 is 2, so that's 0, carry the 1. 0, 1 and the carry is 2, so write down 0, carry the 1. 0, 1 and 1 is 2, so write down 0, carry the 1. And again, I've gone beyond my 4 bits into 5 bits. The computer will not throw an error, it will just ignore, and I've grayed out the 1 to give me the value 0, 0, 0, 1. And if I look back in my table for the pattern 0, 0, 0, 1, it's the value 1 again. So 2 minus 1, add them together, gives me the value 1. So 2 minus 1 is 1. Correct. Let's do the other one. Let's do the 1 take away 3. So I'm going to end up with minus 2 as my answer. But I'm doing it in 4-bit notation this time. So again, write down the 1. That's the bit pattern for 1. This is the bit pattern for minus 3. So if I look in my table, minus 3 is here. It's 1, 1, 0, 1. I write that down as minus 3. Then I add those two together. So 1 plus 1 is 2. So write down the 0, carry the 1. Nothing plus nothing is nothing, plus 1 is 1. Nothing plus 1 is 1. Nothing plus 1 is 1. My answer now is 4 bits. We're okay. I haven't got to even think about any overflow. So take a look back in my table at the 1110, and I find it here, 1110, and that is the value minus 2, which is the correct answer. So 1 take away 3 is minus 2, and this is how we do it in binary. We have a lookup table that we look up the negative numbers. So again, just to reiterate, we can't just say that this is minus 1 by putting a 1 on the front. Minus 1 is 4 ones. So be very, very careful. See if you can understand why that is happening. So let's do another one. I wish this would go away. I'm losing my minus 1 at the bottom there. Oh, it has. So let's do minus 1 take away minus 3. This is a little bit harder because we're doing 2 negatives. So the answer is going to grow in the negative. So minus 1 minus 3 is minus 4. So let's go and find minus 1. That's all 4 ones. Let's go and find minus 3. That's 1101. Write that down and then add them together. And I'm not going to go through it all, but the answer comes to 11100. 5 bits. Don't forget we're in 4 bits, so the overflow bit is grayed out and not used, and I end up with the pattern 1100. So if I take a look in my table for 1100, it is minus 4, which is the answer that we were looking for. So we're doing subtraction by adding. The strange thing that we've got is this second number, this minus number. It might be nice to come up with a better way of doing it. So for example, if I've got 2 to the power 8, that gives me 256 different variations. If I am doing signed numbers, half of those are going to be positive numbers. So I've got the positive numbers down here, and I've changed out what I did before. I had a little minus sign there. I've changed it for a colon so you don't get distracted by 2 negative signs. So the first half, so half of 256 is 128. So the first half are all positive numbers. Everything that start with a 0 is a positive number. There's 128 of them. Don't forget to include the 0. So that is the value for the positive numbers, 127. So that really is 128 numbers. The range is from 0 to 127. And then I'm in negative numbers, but I can't just move on. Well, I could do, but I'm going to start at the very end with all the ones is -1 and then work my way upwards. So I'm putting negative numbers in front of them. And that goes all the way up to -128. So half the numbers are positive, half the numbers are negative. All the positive numbers start with 0, all the negative numbers start with 1, and there are 8 bits. So in signed numbers like these, the first bit, the most significant bit, is either positive or negative, and then we use the next 7 bits here for the actual number. Now we're going to use this table a little bit, not a great deal, in the next set of videos to sort of use 8-bit subtraction. So let's just move on